welcome back to Mr. G Does Maths, another one of the problem questions. I really like this question, as ever. It's very much GCSE level maths, if not actually a bit below. I'm trying not to give too much away here, but you shouldn't find you're using some very difficult maths. The algebra can get a bit more tricky, but again, nothing too tricky or too difficult. Just to explain the question really quickly, because obviously I know exactly what it is because I made the diagram. So you've got 1, 2, 3 semicircles. The 2 with the line represents the perpendicular height up there. I've also just realised I've left 5 marks in. I set this to my year 10s. Quite a few of them managed to get it. So let's see if you can too. So nice and straightforward. What is the yellow shaded area? Pause the video, come back in a few minutes. What do you think? You've got an answer. Okay, so problem with this question, and it's going to happen a little bit now, is I would have done it a certain way, you may have done it a different way. Absolutely fine, no problem with that at all. I think arguably the way that I've done it is the most straightforward way, but there may well be different ways which gets you the same answer. My way is I'm going to think about working out the large semicircle, which I'm going to call 1. I'm going to give that a radius of r. And I'm going to take away the smaller circle and then take away the other smaller semicircle over here. Now it must be the case if the radius is r, then this value here is r as well. My strategy, as I say, is going to work out 1. I'm then going to take away 2, and then I'm going to take away area 3. And then frankly just hope it all works out. Okay, area 1 is probably the easiest one, as we all know the area of a semicircle is going to be half times pi times r squared. Nice and straightforward. To work out the area of the second one, I've got an issue, because if I look down here, I can see the large radius r, but that doesn't help me at all with semicircle 2. So I'm going to have to introduce something else, which is really not ideal for most questions, which is I'm going to have to introduce this value here, which I'm going to call x. And that's the difference between the centre of the large semicircle and the end of the diameter of my smaller circle. And actually, as you'll see, it also plays a part in semicircle 3 as well. And the reason it plays a part is because the diameter of semicircle 2 is going to be the large r minus x, which means the radius is going to be the large r minus x divided by 2. And therefore this means if I zoom over to here, that means I must be able to write the area of this semicircle as a half times by pi times by r minus x all over 2 all squared. Now I can simplify this slightly, so I'm going to do that now. I can actually simplify this over here, so it's going to be r minus x squared, and I can actually square the 2 because I know 2 squared is 4. And I can actually go a stage further and multiply the denominators together, which is going to be 1/8 pi times r minus x all squared. Doesn't look a lot simpler, but we'll see how it goes. Okay, again, I'm answering a circle question. I'm trying to work out the area of semicircle 3. To work out a semicircle area, or any circle area, or sector, or whatever it might be, I need the radius. The radius here is going to be half the diameter. There's my diameter, which means my radius is going to be that. You'll start to see something which you can feel a little bit hopeful here, that things start cancelling, which means the area of my large semicircle is going to be a half times pi times r plus x all squared divided by 4, very similar logic, which I can also write as an 1/8 times pi times r plus x all squared. Now I just need to put this all together and frankly cross my fingers a little bit. So let's write it out. So therefore the shaded area is going to be a half times pi times r squared minus an 1/8 times pi times r minus x squared minus an 1/8 times pi times r plus x all squared. I notice there's an 1/8, was a half and an 1/8, but I'll come to that in a second, and a pi in every term. I can't take anything out of the brackets, I'm going to have to expand those. So let's factorise out an 1/8 pi first, just try and tidy it up a little bit. And that's going to be an 1/8 pi times 4r squared, because I want the half to be replaced by 4, so when I multiply them together I get a half, minus, well, I've taken out an 1/8 pi, so it's just going to be r minus x all squared minus r plus x all squared. Okay, now I'm starting to feel a little bit better because I can see things are going to cancel here, but these x's aren't going to go away. So let's again basically hope. So that's going to be an 1/8 times pi 4r squared stays as 4r squared minus, I'm really careful here with my double negatives, so I'm going to minus r squared minus x squared minus 2rx with a minus makes it a plus 2rx. And then similarly here for this one here, I'm going to expand this, so that's going to be a minus r squared minus x squared plus 2rx becomes a minus 2rx, and I've got this down here. Then start collecting terms, so I've got an 8 times pi, 4r squared minus r squared is 2r squared, minus x squared is minus 2x squared. I've got a 2rx minus a 2rx cancels out, and that leaves me with this. Factorise out the 2, which is going to give me 2/8, which of course I'm not going to leave it like that. I'm going to write that as a quarter. So that gives me a quarter pi times r squared minus x squared. And then I'm stuck, because I don't know what r is and I don't know what x is. So let's go back to the diagram and let's see what we can do. Now if we look at the diagram down here, you can see we've got the x and we've got the 2, but the one thing I do know is I know if I join these things up here, that's a line that comes from the centre, so that must be an r, and I've got a right angle triangle. So if I do a little bit of math on the side, if I draw it down here so it's clearer, I've got the 2 here, I've got the x here and the r here. By Pythagoras' theorem, it must be the case that r squared equals x squared plus 2 squared. R squared minus x squared equals 4. Let's call this equation 2. Not helpful, let's call it equation A actually, so we don't get confused with the 2's above. So let's call that equation A. If we look at equation B, I can see that r squared minus x squared is there, r squared minus x squared is there. I'm feeling quite happy about this. So that's going to be a quarter pi times 4, which means my final answer is pi. That's it. Love that question, mainly because the answer is so beautiful. Please do the usual, like and subscribe, leave a comment if there's anything you want me to talk about.